Hello everyone, welcome to day 4 of Unit 4, Quadratic Relations Part 2. Today we are going to be solving equations, so quadratic equations by isolating our variables. Just to review, remember if we have a quadratic equation, pretty much in any form, but I'll use standard form as an example. So let's assume this is a quadratic in standard form. We can't solve the quadratic equation by isolating the variable because our quadratic equations have an x in two different terms that can't be combined. So we have both an x squared and an x term. So you couldn't simply rearrange and isolate these variables because you actually have two unique variables in your question. So instead of isolating, we learn to solve quadratics by moving everything to one side and factoring. So whenever we're asked to solve a quadratic equation, we need to find the zeros or the x-intercepts. We should know that. And in other words, we're solving for x. When we go through the examples today, some of it is going to be factoring, and there'll be other parts when we only actually have one variable in our problem where we can in fact rearrange the equation, make one side of our equation equal to 0, and then solve. For this, let's just start with a couple factoring exercises and solving these. So whenever you see the word solve in these problems, it means we need to find our zeros or our x-intercepts. Okay. Well, here we notice that we have three different terms, x squared, 7x, and negative 12. However, that negative 12 is on the right side of our equal sign. In order to factor or solve this, we need to make sure that everything is going to be on one side of the equal sign. So we're going to have to bring that negative 12 over to the right or the left side. That means when we bring something across an equal sign, the opposite operations tells us that it now becomes addition, and this side is equal to 0. We can go ahead and factor that now. So remember, factoring, we would set up our t-chart. Okay, we're looking at values that multiply to c and add to b. So our c value is 12, our b value is 7. Our two factors would be 4 times 3 or 4 plus 3. So factoring by decomposition, you have this, and again, decomposition is splitting that middle term into the two factors you came up with. Next stage, you're going to simply want to group your terms and factor or common factor each of those pairs. So what's common amongst x squared and 4x? X, leaving you with x plus 4. Okay, what's common with 3x and 12? Well, that's 3 and x plus 4. Okay, if you notice, you have the same in brackets. What's similar? That's x plus 4. What's left over? That is x plus 3, and you factor this. However, you haven't solved it. In order to actually solve it, you need to determine what the real zeros are. And in order to do that, you want to set both factors equal to 0 and solve. So we've done this before, but as a review, so if I took this factor here, x plus 4 equals 0, I want to solve for x, which means I'm going to have to bring the 4 over. Therefore, my first value, or x1, is going to be equal to negative 4. Okay, same thing here. X plus 3 equals 0. If I bring that over, well, that means that my second value of x is equal to negative 3. Just rule of thumb, it's always opposite to the sign that you see in your factors. So you saw x plus 4 and x plus 3, and you see that your values here are negative 4 and negative 3. Okay, so if you solve it, that is all the work. Let's go on to the next one. So if you look at this next problem, you have x squared minus 25. Here, we're missing our b value or our middle term. Okay, and let's just recall types of factoring problems before we actually try and go on this. Another word for subtraction, which you see right here, okay, is difference. And the number 25 should jump out at you as being a perfect square, meaning it's 5 times 5. Therefore, this whole problem, is in fact a difference of, this whole problem is in fact a difference of squares. Okay, well, how do we factor that? Well, we just look at both terms separately. We're going to take the square root of x squared, which is x. We're going to take the square root of our second term, which is 25, which is 5. And therefore, our result is x minus 5, x plus 5. Okay, that's how you would factor that using different squares. Same thing, we're going to come up with x1, which would be positive 5 here. This one would be x2, which would be negative 5 if you were to set those equal to zeros. And then these here are your solutions to the problem. Okay, but notice that in problem B, we didn't actually have both an x squared and an x term. So we only had one variable that we needed to solve for, which we could do. So let's try this in a different way. I'll rewrite the problem, which is x squared minus 25 equals 0. Okay, let's do our best here to isolate our x squared term. Okay, meaning we want to get it by itself. If we do that, let's bring this 25 over. It's left with x squared equals 25. Now, in order to solve for x squared, we need to do opposite operations. So we're used to the process, if this said 2x equals 25, then we would divide both sides by 2. But because it's opposite operations, this says x squared. Well, the opposite of operation, or opposite of squaring a number, is taking this square root. Okay, so whenever you see that x squared, you want to take the square root of both sides, which means you're going to be left with x is equal to, and just ignore this for a second, the square root of 25. Now you notice I put this symbol here of plus minus. Every time you take the square root across an equal sign, you have to take the positive and negative answer. So, well, what does that mean if you take the square root of 25? Well, you're going to have two values here. You're going to have both equals positive and negative 5. Therefore, x1 would equal negative 5 and x2 would equal positive 5. So you're always just going to have a positive and negative answer. Okay, let's try a couple other examples here. I have two before you get going on some of your assigned work for the week. So here we have in example 2a, we have parts that kind of look like vertex form. So what we want to do here is, first thing is bring everything to one side. Okay, well, if we do that, then we're going to get, let's just bring everything to the left side, which means that 90 needs to come over, it's subtract 90 equals 0. Okay, if we collect our like terms, we're going to have negative 100. Okay, I want to now isolate for this x variable, which means I need to get it by itself, and I'm going to have to rearrange my equation. So I'm going to bring that negative 100 over to the opposite side now, and it becomes positive. Okay, the next thing I need to do is, you always look at that coefficient in front of the brackets. Well, this is what multiplication would be, so we're going to divide both sides by 4. Okay, that leaves us with this eliminating, we're left with x plus 3 squared equals, well, that's 25. This step right here, you're going to ignore what you have in the brackets first of all, but then you're going to take the square root of both sides. So if you take the square root of the left side of your equation, you're left with x plus 3, because that would cancel out this operation here. Now, you take the square root of 25, remembering we have to take the positive and negative version. And the last step to isolate x would to actually bring that 3 over, leaving us with just x. This is going to be now negative 3, and it's going to be plus and subtract 5, because that would be the square root of 25. Therefore, our first value of x would be negative 3 plus 5, which is 2. And our second value of x would be negative 3 minus 5, which is negative 8. Okay? So that would be following steps to isolate for a term. And then we'll do one more. It looks almost like the problem we did originally to start today. It's just a little different because we have a leading coefficient here. So the first step, if you see a problem like this, is you want to divide by that coefficient, both sides. That leaves you with just x squared. Negative 18 divided by 3. Well, the negatives will cancel out, so our result should be positive, and the answer is 6. Now we know that we have to take the square root of both sides. That's the square root of 6. This isn't going to be a whole number, so a decimal here is fine. Well, the square root of 6 is 2.45, and we just know we have two solutions because we're working in quadratics. That's positive and negative 2.45. So use those examples to kind of help you. The assigned questions here are on the back side, so they look similar to what we did there in example 2a. And if you continue to look at these questions and go through them and you're comfortable, that's great. All the answers are just below there as well. So best of luck.